when you see that we have metadata, so the metadata is to be um, occurred, and the tools which are all using the data, so they need to connect with the metadata, and then the metadata is to be stored separately. So that is how the data warehouse also working. We have a metadata repository over there. So here metadata is also automatic. So we need we don't need to uh, manage them also. That means that Snowflake can scale near linearly. So whenever your compute resources are scaling out. So that is how the scaling is happening. And that is how the Snowflake is also handling the scaling, right? So it is secured by design and compatible with the popular ETL and BI tools. So we have seen in the previous screens, so where we are having a connection, the connectors are available. Snowflake is providing a lot of connectors, so it can be compatible with any other tool. And virtually unlimited concurrency, so that can support the enterprise-wide data warehouse requirements. So how much parallel processing needed, and how many of the users we need to connect with, so we can connect over there. Then powerful query processing, so which is um, created for the developers for multiple platforms. So we can have a powerful query processing, and this processing and the storage both are being taken from the cloud computing only, right? Either AWS or Azure or Google nowadays. Okay, so these are the areas where Snowflake is scoring. And history is about they have been launched this 2012, but in 2014 only launched this in stealth mode by Bob Mugila. Bob, he was ex chief in Microsoft. So he took over Snowflake. He appointment as CEO, and he was been developed the market later on. We have three founders here. You can see that Benoit, Thierry, and Marcin. So these are the three founders over there. They are all, most of them, those two are ex-Oracle people, right? So then in 2015, they had only 80 companies over there. So after 2017 only, it started. People were seeing the advantages of Snowflake and coming over there. And the marketing also was very good for them. So now you see that it is more than 3.5 billion value, right? So that is how a small history of Snowflake, and you can see the growth of Snowflake also. And if they take another evaluation on 2020, definitely it is going to be very higher. So when you talk about the architecture, so we need to understand this architecture can be split into three layers. So three independent linked layers. So that is how we define it here. So when you have the first layer of them, we have this service layer. So the service layer contains multiple services. So it will be running over in the Snowflake level itself, where the end user are accessing any one of this service, and they can request what they want to be, what they want to do with these Snowflake data warehouse. So transactions, security, or any management, sharing of data. So any of them are provided as service, right? So these services are located in Snowflake. Then the next layer is the compute layer. So the compute layer is the one which uses the computing services of the cloud service. That is, whenever I'm talking about cloud, you need to take it as any one of these three cloud services. Okay, AWS, Azure, or Google Cloud. So when you want to load data, when you want to do some analysis over there, so when you're into a development, So any one of these process needs to use this compute service only, compute layer only. So this compute layer is independent one that is being linked to other layers, but it is working independently. Okay, it operates independently. Similar to that, we have another independent layer, that is what the storage, the final one. So this storage also is being stored inside the cloud. So Snowflake is having the services on its own, and it uses the compute and storage from the cloud services. So that is how it works. So because of this is taking from the cloud, it is easier for Snowflake to use this scalability and elasticity of the cloud computing, right? So that is how it works. Services are the brain of the Snowflake architecture, where these apps, service apps, are being stored here in the Snowflake level, and it is responsible for all the operations, whatever you do, authentication, management, so any security or any query compilation and optimization of the query. So all of these are being done within these services only. So they need to coordinate all the transactions together so that any of these transactions you are providing, so that is be coordinated inside the services itself. Services will take care of all. And it can run on multiple availability zones. That availability zone is about where your data and metadata, everything is being located. So whenever you are choosing any availability zone, so this um, services can reflect this data, replicate them into multiple availability zones, so that you don't need to worry about managing them. And highly available, because of this distributed nature, it is highly available. Any failure or any other uh, uh, disconnection of your data, so that is not going to be affected the process. So everything will be highly available over there. And similar to the cloud security, Snowflake also have a very strong security. So encryption, key management, which has been enabled for all the SQL DML and DDL functions. So whenever you are providing a function, whenever you execute any queries, so these are all very secured manner it is going to be executed. Okay. So when you come to the next level, next layer, that is the compute. So query processing takes place here. So whenever you are executing a query, the query processing, all of your um, commands are in a query based only. So you are not going to execute anything other than a query. So we call them everything as query. It is based on ANSI SQL, and it is having some additional queries also. It is not purely ANSI SQL, but based on the ANSI SQL, and it can have additional queries also over there. So it is designed to process the uh, enormous quantity of data with maximum speed and efficiency. And it can be performed on one or more clusters of compute resources. So we call them as virtual warehouses. So some small um, the termination is being like that. So here in Snowflake, warehouses means these are all processors. These are all not storage. The storage is being called as databases only, right? So we call them as warehouses where we are doing the process. So this compute can retrieve only the minimum data required from the storage layer. So it will be seeing the requirement, that is the query, and according to the query, it can reach whichever the data is only required, and it can take those data alone. So it doesn't need to take the whole data like our traditional row-based storage, right? And caching, like any other data storage, it uses the caching. The caching can be done locally with the computing resources. So rather than taking the data from any other location, any other zone, so it can cache them locally, and it can be um, used in a faster manner. And the caching is done in the warehouse only, right? So it uses a memory so that it can be cached over there. And multiple warehouses can simultaneously operate on the same data. So you can operate multiple warehouses, that is different compute services, on the same databases. That is one thing. And another thing which I have not mentioned here is you can have um, one single compute that also you can possible to operate on multiple databases, right? So vice versa, you can do it. Storage is built on scalable cloud blob storage. So in the cloud, if you have the understanding about how the cloud storage has been happening, so we call them as blob storage, where you can store any kind of thing. It is not a table kind of storage. It is not a relational table or something like that. So blob storage will allow you to load even unstructured data also. So that is what the blob storage is about. So Snowflake is using that blob storage, which is called as S3 in AWS, and blob storage in Azure. Okay. So it can hold all the diverse data, tables, query results, everything. Whatever you meant for storage, it is being kept in this storage area only. It can assure the maximum scalability and the performance capacity. So when you are talking about a storage can be scaled in a uh, in a linear manner, and almost in an infinite storage you are having because of the cloud system, right? So it is very much useful for our data warehouse and analytics purpose, and it is been engineered to scale completely independent of the compute resources. So your compute resources will be the same, but your storage can expand at any point of time, right? So what happens here is, because of this process, data loading or unloading can work and without the impact of other queries which are running for any workload. So whenever you do some analysis, this happens not of time. When the data is getting loaded, so the analysis process also can get slower. So here, all of these layers are independent. Your compute is an independent one, storage is an independent. So that will be carried over separately. The loading will be carried over separately, and your process, that is the analysis process, also will carry over separately. So that is how it works, and that's the advantage of this one. And the next thing is about the micro partitions. So we store data, Snowflake is storing data as micro partitions, right? So what do you mean by a micro partition? So micro partition are some columnar storage, it is, and it is stored in small chunks of data. Rather than storing the data in one single partition, it creates partitions. um, Maybe in other traditional data warehouse system also, we are storing data in partitions. But here, the partitions will be very small. Okay, so I'll explain you a little later on. So the data is loaded automatically and split into the modest size micro partition. So it will be sized, the size cannot exceed 500 MB. If the size is exceeding 500 MB, Snowflake will create one more partition and it will store the data. Okay. So metadata is extracted to enable efficient query processing. Separately, it is being extracted over there. So micro partitions are columnar storage with compressed. The data is compressed and stored. So how much data you are taking, the storage will occupy only less space after compressing them, and it will be encrypted also. It will be, while storing itself, it is encrypted and it is stored with a security key, right? So that is about the storage we have. We'll see more about storage later on, because that is one important advantage we have. That is the positive point about the storage, right? So independent storage and compute layers. So that is the main thing about the Snowflake architecture, and it instantly scalable. So you don't need to wait for any um, expansion of your capacity. Then these activities or the actions, whatever you are doing, or the processing, they are all independent. So whenever you do any one activity in one virtual warehouse, it's not going to impact in other warehouses. Multi-clustering for unlimited concurrency. So multi-clustering is about simultaneously, parallelly, we are going to do the processing. So we don't need to worry about whether we are working with a few users or multiple users at the same time. So multi-clustering will be helping for us. So whenever the number of users are increasing, so automatically Snowflake can increase the capacity, that is the computing capacity. So virtual warehouse can increase the capacity. Then ACID integrity across all values. So the atomicity and the other um, rules. So whichever we are following about loading data for the data storage. So that is also being maintained by this virtual warehouse. Transaction commits are immediately visible to new queries running on. So whenever you are loading data and whenever you are doing the process, these are separate process happening from separate ends, separate locations. So, but the transaction commit will be happening immediately. Once the data is loaded, you don't need to do refresh of data for analysis purpose and that. Immediately that will be available for the other process also. So that is one very big quality where you will save a lot of time for a refreshing process, right? So that is one thing is over there. Obviously, with this kind of architecture, Snowflake outperforms
So
all the, yes.
Murli, in the previous slide, so we doesn't have any rollbacks concepts here.
No, rollbacks, we can control the transaction. What they are saying here is, so we can control the transaction, obviously. What we are defining here is about whenever you are having a commit, whenever you do a commit,
Go and get it.
the data is visible immediately to other process also. See,
Okay.
you have taken one data, you have applied a query and you have taken a data. For example, select star I have given. That means
Mhm.
all the data should be visible for you, right?
Okay. Yes.
So after committing this query, you are doing some data load. So that data might not be visible normally.
Before the commit.
Yes.
Okay.
Other data. No, after commit I'm talking about.
Okay.
See, you are running a query, select star, you are taking all the data.
Mhm.
Someone else is loading data at the same point of time,
Right.
right? When your query, select query runs first, after that the inserts is happening. You will not be able to see the data, no?
Yeah.
Normally.
Yeah. Mhm.
But here it is not. You don't need to refresh them. Whenever your query is running, immediately the data can be visible. That's what they are doing
Okay. Got it. Yeah.
because
Thank you.
of this storage process. Okay.
Yeah. Sure. Thank you.
So the same process performance has been uh, very much improved than the traditional methods. It can deliver the query results in a fraction of time when compared to the on-premises systems. Uh, we can set a size for a virtual warehouse and it can be resized even while running, right? Normally, if you talk about this kind of quality, a property of Snowflake, imagine you are working with a huge server where it is having multiple cores available and a huge memory also available, lot of TBs of memory available over there. So if you feel that in the next 1 week, I need to have multiple users will be accessible. So we can just take one small example like a Flipkart or Amazon online sales, something like that. So they will be providing some flash sales or something like for Christmas or New Year within this 1 week. You will be having a flash sale or some new mobile model is being released so that um, a lot of people will be coming over there and buying on that particular time. So what we can do is whenever the users are increasing, we don't need to set them initially. I'm sorry, we don't need to increase them initially. We just set it Just a second, please. Just a second. Okay, sorry about that. I had call about this. So you be having a high demand on a certain period only. So whenever your demand is increasing, if it is in on-premises, what we have to do, so we are going to manage this, we are going to maintain um, the resources, all hardware and software. So we need to increase the capacity of the hardware. So when you are increasing the capacity, it is like a small a little pass will be there for that process. So you need to add them together, and we have to switch over all these process into that particular hardware systems and that, right? Then we have to increase the capacity of your storage. So where you have to add more kind of hardware again. And you need to set up all the kind of software which are all required over there, and the existing database. So how we are going to share these databases, everything else has to be done manually, where it may take time and it may have some little effect, little small kind of delay will be there whenever you are providing any changes in your software and hardware in a bigger manner. But when you talk about this cloud system, particularly in Snowflake, we don't need to worry about whenever you are scaling your virtual warehouse size. So just running, it is running already, and a lot of people are accessing those things. At that time itself, you can increase the capacity even while running. Okay, so that is what it is having, and that's what good advantage of that. And another very important one is whenever you are increasing the capacity on premises, that will be a permanent one. So where you have some, for example, you are having a 8-core system, you change it to 16 core. From 1 TB, you are changing into 2 TB of memory, and storage capacity, the hard disk you are increasing. Anything else is going to be a permanent one. After this 1 week or something, you are not going to have that much of transactions happening. The transaction will drastically be reduced. At that time also, you will be having the same capacity over there, right? So that is the disadvantage. What we have here is we need to do it manually. What that is one thing. Another thing is you need to pay in upfront for all this infrastructure improvement. So, but Snowflake, what it do is you will pay only for what you use. So the computer resources, whatever you are being scaling up, that will be used, that can be used only for a certain period. You can specify. So whenever that period is over, so you expect a normal kind of transaction only is going to happen. So we can scale down also. Scaling down will remove all the additional sources. So the 2 TB will become 1 TB, and the cores of computers or the number of servers can become normal. It will be reduced. So that is what you are paying only for what you use, right? So automatically it can scale up and automatically it can scale down. And the process also, it will be fast. That means that virtual warehouses are running continuously, they are running. For example, if nobody else is been hitting, that means nobody else is executing any query, nobody is using that virtual warehouse, the virtual warehouse can go to a suspended mode. So it will be giving a pass. So if it is suspended, you will not be charged for that one. So that is a very nice thing for when regarding the cost of this one. So what happens here? It will be waiting until a person, until a query is being hit there. So whenever a action is required, it will resume automatically, and it will do that one without any delay of, without any fraction of second delay, the process will happen. Okay, so that is how the virtual warehouses are working. So it is very economical for using a Snowflake architecture. Okay, so that is how it goes. That is how it scores actually, right? Storages again are, they are measured on month per month you are going to pay for storage and measured in TBs only. So even if, for example, if I have been concerned, means I'm not going to store in TBs. I have my account in Snowflake, means I will not be going to store in TBs. I'm going to less than that only. But anyhow, whatever storage you are doing, it is stored as, it is being calculated as TBs. So if you are having zero point 0.5 TB, 500 GB you are having, that also will be calculated as one single TB only. If you have 1.5 TB, it is calculated as 2 TB of, right? So per month you need to pay for that. And this storage capacity is calculated after compressing only. So your real-time data might be bigger, more bigger than that. It is being compressed and then it is stored. Automatically it is compressing. Automatically the decompress also will happen when you are accessing the data. So for compressing and decompressing, there is no charges for it being occurred for in Snowflake, right? So that is how it happens. So storage becomes very inexpensive when compared to our normal storages, and it can scale virtually also. Virtually indefinite scaling can be possible. So multi-petabyte databases can provide you a very high performance. So I'll be showing you the real-time performance reports. So where many other uh, clients of Snowflake, so they have given the reports over there, how it was earlier and how it is after implementing Snowflake. So that is how you can see a very huge difference about the performance. Then querying and loading of both structured, machine generated, semi-structured, all are using the relational SQL operators only. So you can use a normal SQL, ANSI SQL, and you can connect with and you can operate on any type of data available over there. So that is one of the biggest advantage we have. And similarly, schemas are dynamic and automatically detected on load. So whenever we want to execute a query, so we can store these tables under some schemas. So we know that hierarchy over there. Have databases, you can create multiple schemas over there, and it can be stored inside tables under that. So this structure is being followed, and these schemas can be detected. So where you have taken from the data and in which table you are going to load. So it can be detecting that schema automatically, and it can load the data in that particular manner. So you don't need to specify all of this information, like how it is being carried over in Hadoop or some other data warehouse systems, right? So that is how it is being used over there. So what other benefits we have? Availability and security. This is one of the important factor of data warehouse system because of the highly shareable data. So you are providing an integration data, and the data should be shared across. So high availability is one of the main requirement of any data warehouse system. So that is a natural thing in Snowflake scale out architecture. It is very highly available, fully distributed across multiple Amazon and Azure availability zones. So any failure happens, we are not going to lose any data. So that is what it tells over here. So I have mentioned Amazon and Azure, but it is available on Google Cloud also. But the Google Cloud is being added very recently. So it is not supported on multiple zones for Google. Maybe soon they are going to add all the zones over there, right? So any hardware failure which occurs very occasionally, it is going to occur, but any hardware failure, if it is occurring, you are going to have a very minimum impact of that one. So that is what this fully distributed zones are been telling us. Then it supports two-factor and federation authentication with single sign-on, and you will be provided a roles. So how you are a SQL access admin or you are an account admin, something like that. So based on these roles, so this authorization will occur, right? Like any other database. Then we have limited access to the client addresses by policies. So you can provide policies and who are all can access from which client address you can access. Like that we can provide the policies. So policies help us to minimize the usage of any um, storage device. That means that if you have one kind of one client address, so you can provide a policy. So from this client address I can access only a certain storages. Like that you can provide it, a kind of a rule we are creating. So that rule will limit the access, so you can provide security and more efficiency also, right? So SOC2, this in US we are providing these kind of certificates. So these are all available on both AWS and Azure, now in Google also. And this HIPAA customers with the in the people who are in US, you will be knowing about those kind of stuff. So all of these standards are supported here, right? Then data is being encrypted in motion or the internet or direct links at rest disk. Anywhere, wherever you are talking about the data, whenever you are loading data, the data, whenever transaction is happening, it is encrypted and it is being transacted, right? When you are loading data or you are extracting data, both ways, it is being encrypted, all the network communications, and it is being transacted over there with encryption, right? So while storing also it is encrypted and stored, and while you are transacting also it is encrypted and transaction happens over
So the
there. Data,
encryption,
yes,
will be happening at the virtual warehouse level. So virtual warehouse is a place where the uh, I mean, like all the compute information is fetched, right? Um, so virtual warehouse is a place where the encryption will happen in and out.
yes, yes.
Okay, thank you.
It happens on both ends. It happens on the storage also, because while storing itself, it encrypting and storing it. So it is secure. Even anyone wrongly they are accessing, somehow they have access means that also it's been encrypted. So it is very safe for us.
Got
While
it.
the
Noted.
transaction is
Thank you.
happening also, if any hack is happening, someone else is hacking us and all. So that also it's been encrypted. So that also they provide its security.
Sure. Thank you.
Okay.
Got it.
Data sharing is another challenge when you are working with any data. So how you can share and what you have to share, and how the process of sharing, how we can secure the data and seamless sharing. So these are all some challenges we have. So we are not going to copy or transfer data from one account to another account. So accounts, we are going to create accounts soon. Accounts are something like where you are going to create your account in Snowflake. So one of the account, whatever you are creating, your operations will be done within that account only. You cannot do account. For example, I'm telling you about. So you create one account, and I have my own account in Snowflake, right? So we can create a free account also now. Then we can change that to a paid account if you want, or you can remove them. Okay, that is fine. So if a company, if an organization is having an account, so it has to share data uh, with its associates or clients, whoever. and those people also may have another Snowflake account, right? Even though we both are having Snowflake accounts, we are not able to share the data between them. uh, that means that my account data you cannot come and see, your account data I cannot see. So if you are creating a user in your account, then only you are going to allow me to see your data or allow me to access your data, right? So that is how it works. But when you are sharing it, so we are able to share the data with other accounts also. It is not necessary someone needs to create an account to access your data. We have another kind of account called as reader account, so which will allow third party also to access your data. Okay, so that is how it happens. So what happens here is we are not going to copy or transfer any data. We just allow the user to access our data with the same location itself, right? So it is grant secure and curated access to read-only copies of the data, to particular data, whichever you want to access them. For the particular database or particular table, you can provide access to them. So it will be stored in this. Okay, it is being stored in the same storage area, but the access only is being given to them. So when a person is accessing from another account, the charges for computing will be done for him, not for you. But the storage charges will be for you. The storage charges will not have additional storage charge for sharing purpose, right? So these and all we will be talking about when we are going for practicals, definitely. But I'm just telling you a overview of this sharing. Okay, so we are going to do all of them in a practical manner, right? So what happens here? You have your data warehouse system, you have your storage. This storage, if any other user wants to share, you can share across multiple accounts, and you can share across people who are not having Snowflake account also, right? We have small difference between that reader account and consumer account. These two accounts are there, right? Then the same security is being applied, whoever accessing the data. It is not going to incur any additional storage charges. Compute charges will be there because when you are accessing an account, the consumer is going to execute a query and get the data over there and or use the data, right? So for that, you need to have the compute resources. The compute resources of that consumer will be charged, right? Not for us. Then shared data can easily be combined with the data of consumer's account. So even though it is a read only, so you can combine the data within the existing data of the consumer. So for example, I am a consumer, I am going to get the data of some other person. He is sharing with me. So what I can do is I can get the data of them and share my data also. Together, I can do some analysis and get some results over there, right? So that is what it is working on. Then this so okay, so this is how the sharing is occurring, right? So it eliminates all the kind of traditional sharing what we have done earlier, and sharing is done through easy to use SQL functions again, right? All of this um, whatever action you are doing, whatever activities we are taking place in the Snowflake, it is being done using the SQL only, right? So you are going to use the SQL function for every other action you are doing, right? Then finally about the security and compliance. So security we have seen so far. So how the data is being secured while in rest and while in traveling also, right? When in transferring also. Snowflake provides encryption, and it is providing the certificate, secured certificate also it can provide. And it can provide multiple list of reports to all customer and prospects. So we have multiple type of reports where we are following the security norms which are provided by the government agencies, right? So in US, UK or European, so they are providing some kind of security methods. So Snowflake follows and it adapts all of these security over there, ISO, HIPAA, FedRAMP, whatever we are going to provide it, right? So that is what Snowflake is providing us. So that's the thing. Okay, so we have a Snowflake architecture. I can just show you over there. So this is how it looks like. The database storage. I have given an example on Amazon AWS. It is the similar. You can just compare if it is provided in Azure, how it will be happening. If it is provided in Google, you can compare them easily, right? But basically, database storage, virtual warehouses, these are all two independent um, layers, right? Then cloud services. Then after that, the user interfaces. So where you can have any kind of drivers or web UI. Then you have the tools also. It's happening over there, right? So this is how you are having another picture. You are seeing that same picture. I'm just splitting into that. So how the DML and DDL are been happening and how internally the data is stored. So we have seen earlier data is stored in S3, but how internally they are stored. They are stored in small chunks of data that is called as micropartitions, right? So these micropartitions are created and it is maintained by the Snowflake services, right? So that is how the query management service that will be um, taking care of this. Okay. So each of them are clusters. So they are having different clusters of data, and it is stored in multiple partitions together. Okay. So this is how this compute is providing different nodes together in one single cluster. It can provide different nodes. So each of the node you can imagine as a separate computer, separate processor. So the processing can happen in a very quick manner, very efficient manner. So every user, so they can use one or same or different clusters here, right? So for loading purpose, we use some kind of cluster, and for some other analysis purpose, we use some other cluster. So that is how it happens. Okay. Then one very um, important factor or important um, the part of the architecture, we call it as micro partitioning. Earlier, you have seen that the data, whatever we are storing into Snowflake, it is being stored in a cloud storage area, that is a S3 or something like that. In that itself, so we are going to store it in micro partitioning only. So data is being stored as columnar storage and it is stored in micropartitions. So why we call it as micropartitions? Unlike other traditional databases, your partitions are not going to be bigger, right? So it is going to be very small. Yeah, I have mentioned the size over there, 50 to 500 MBs only in uncompressed format, right? So in the compressed format, it may be less, but in uncompressed format, this is the storage. So whenever you are going to store data, this the size of the data will be calculated and it will be storing the data into the partition. Once the partition is filled, that is the 500 MB is reached, it will create one more partition and it will be maintaining that separately. So what happens here whenever you are providing, whenever you are giving a query, um, the query engine will be finding out in which partition your data is located. So it can just go through the partition list of partitions will be available there, and that one it will be providing you the partition number and as well as the maximum and minimum number which is stored in that partition. It will be sorted according to that, and then it is stored over there, right? For example, if you are having a key value of date. So date wise it will be stored. So every date inside that you will be having some, for example, if you are storing a invoice number or any customer ID or something like that. So whichever you provide it as a potential um, column which is used for querying purpose. So based on that column, this data will be stored, sorting with that, and it is stored over there, right? So whenever we are storing data in a sorted manner on the keys, so it is easier for us to find something like indexing, what we are having. Actually, indexing is not happening here, but similar to that, what happens here, wherever your data is stored and what data is being stored on each partition is being maintained separately. So that list only the Snowflake is going to access, query engine is going to access initially, right? So once it is accessing that, it can find out, it can find the match where this data can be located. For example, if you are going for some customer ID 1 to 500 is stored in partition 1. 501 to 1000 it is stored in separate, like that. So it can be stored there, and the starting point and end point, or a minimum maximum value, that will be stored. So you can find out easily, very quickly you can find out, even though you have millions of rows or billions of rows. So you will be accessing only a very few partitions at a point of time. So that is what the biggest advantage of Snowflake. That is why it is going to be very quicker than other traditional queries, right? And it uses the biggest advantage of columnar storage. So whenever you are accessing a column or very few columns, so it will go and fetch only the data from those columns, and other columns data, even though they are related to the same row, it's going to be ignored, right? And columns are compressed individually within micropartitions. So in the micropartitions, columns are placed in a compressed manner only. So you will be able to get the data and decompress it, and then you can provide it over there, right? The algorithm of compression, Snowflake will be deciding it, so which way the data should be compressed. So we have some 4 or 5 way of compressing data. So by default, Snowflake uses this way of computing. I'll just verify and tell you. So one way of compressing is being handled, and you can specify what other ways also if you want to do it, right? So you can compress the data while loading itself, and you can decompress the data while unloading, but that should be done manually if you are using some other compression methods. Snowflake uses some of the methods which is more efficient also, and it can be stored automatically in a compressed manner. Okay. So micro partitions are very much useful. We will see them more in action little later on. Uh, but just keep it in mind, micro partitioning is the way of storing data in Snowflake. Clustering.
Yeah,
So
Murali, I have
clustering,
one question
yes,
here.
yeah,
Yeah, Murali, Subbu here. One more question. This 50 to 500 MB uncompressed partition you told, right?
yes,
Hello?
yes,
Yeah, am I audible?
yeah, yes, yes. Go.
Yeah. I have a file with 510 MB. For that,
Mhm.
it created a 500 MB partition and 50 MB partition, right? Or 10 MB partition.
Yes, that's good. See, when you are having a, which is less than 50 MB, so it is not going to create
Yeah.
additional partitioning. So it is having some kind of value they are giving. 50 to 500 will be anywhere between, right? Why they are giving 50 to
Okay.
500
Okay.
is,
Yeah.
even though some micro partitions, if you are not filling up to 500, it will stop the storing data on that partition. It will, can create one more partition, right? 50 to 500 is the
Yeah.
maximum level they are giving, not the minimum level. See, for example, you are telling that 10 MB is there,
Okay.
only 10 MB your data, right?
Yeah.
That will be stored in
Yeah.
one single
Yeah.
partition only.
Yeah.
That will be stored in single partition, right? But
Okay.
at some point of time, if a table is
Single
extending
partition.
more than 500 MB, that will be stored in different partitions. These two, everyone can understand easily, right? Is
Yeah.
that
Yeah.
right? Yeah. Less than 50 also, it is stored
Yeah.
in
I
one
mean, it
partition.
created partition. Yeah. In that partition size is 50 MB or 10 MB. 50 MB, right?
Okay, no,
Size of
I'll
the
explain.
partition.
Yeah, yeah, your question is very nice. I'll explain you a little bit of. See, it is clearly understandable. For example, if your table is 750 MB, 750 MB. there will be two micro partitioning. Is that right?
Yes. Yes.
Is that right? Okay, 200. Okay. Now, if it is 10
Yes.
MB, 10 MB, if it is 10 MB, it is only one micro partition.
Yeah.
Is that right? Okay. Now, we need to have
Yes.
a question like why they are
Yes.
mentioning 50 to 500. Correct? That means that if you are having a
Yes.
table, if you are having a table where you are having, um, for example, 200 MB is there, so it will load the data into one single partition and it will not load any other data in that partition. Up to that, it will load. Up to 500, it can load.
Okay.
That is what. Anywhere
Okay.
between 50 to 500, right?
Okay.
That is the
Okay.
maximum level. Maximum level.
Okay. Yeah.
Yeah, that
Yeah.
is how it goes.
Okay.
So
Another
what?
300 MB storage may not be used. It may be used
Utilized,
later
correct. They may be used later for that
for
particular
the table.
table. Yes, yes.
Okay. Not loaded for another table data in that partition.
Definitely not loaded. Definitely not loaded.
That's what my question is.
So if we are not utilizing that space, so can it can this has a capacity of unshrinking this space?
Yes, that is another good question. Actually, there is no space left out anytime because it is a cloud storage, it is independent storages. We allocate data means virtually only we are allocating,
Okay.
right? We are allocating virtually. It is not like 500 MB will be kept every time separately. No. If the 200 MB is occupied, only 200 MB will be occupied. No 300 MB will be left out anywhere else. But internally, the Snowflake engine will keep the track like 300 MB is left out for this particular storage. Like that, it will be keeping it.
Okay. Okay.
Right?
Got it.
It's not like 500 MB of hard disk storage, something like that is left out, and 300 MB is empty. No, it will occupy all the space one by one. It will be doing it.
Okay. Got it.
Right? Okay. Because anytime, any number of storage can be taken from the cloud. Anytime, any number of storage can be taken. So it is not going to allocate and reserve the space for that one. No need for reserving it. Okay.
Yeah.
Got it,
Okay.
Manu.
Thank you.
Thank you. Yeah.
Okay.
Yeah. Thank you.
Then another thing which is related with the micro partitioning is clustering. So clustering is what while ingesting data, while inserting data itself, it will sort the data and load it according to the natural dimension. So whichever tables you are following, so it will be storing in that manner over there. And it can co-locates the column data. Whichever column you are loading, columns only are loaded separately. It will not be having loaded in rows. It will be uh, it will be tracking the loads in a separate manner. The rows, which are the rows are related. That means that in which column, what is the row, corresponding row for all the columns. So that will be maintained separately. That is very similar to any kind of columnar storage. Now we have NoSQL data is available now. So all of them are in columnar storage only. So it is going to be stored in that same manner. And that is what the clustering is helping us for us. So as the data is loaded, Snowflake co-locates the column data with the same value in the same micro partition if possible. So if the micro partition is not free, it will create one more, no other way. In one single column itself, if the micro partitioning, it is not having enough data, 500 MB is filled up in one partition. So it will be going to another partition one, right? Partitioning is just a name. It is not going to provide the space or something like. Physically, it is stored, but it is having a micro partition. For example, T1 is one micro partition. The T1, how much is being filled up, that data will be available for Snowflake, this metadata. While seeing that, it can go and fill it up in the same partition. It will name all the data in that same partition, right? Physically, it can be located anywhere. I hope you understand that. Physically, it is not located in one single location. It can be located anywhere, but they are being maintained as in the same name. This data is in T1, this data is in T1. Like that, they are going to maintain in that manner, right? So that is what the way of storing. Clustering is about storing the data in sorting. By sorting, it is storing the data. And whenever you want to recluster them, definitely when your table grows and you are loading erratical way of loading, that is one day you load in day wise data, another day you are loading some branch wise data, you are loading something like that, the load happens. So the clustering keys, clustering can be disturbed on that particular time. It can become stale. So what we do is the query performance, obviously it is going to be reduced. So we recluster the tables. Reclustering can be done by through the queries itself. So whenever you are reclustering them, you can provide your own key also. For example, Snowflake detects which is the way of sorting and which should be the cluster key. Snowflake only deciding that. We are not able to control on the loading time. After that, what we can do, we can say in the close to the Snowflake that this is the key you have to use. So you are loading day wise, but I don't want to maintain day wise. I want to maintain product wise, something like that. So this will be, I'm going to access the data product wise only every time. So we can give clustering key as a product ID or something like that. So the table will be reorganized according to that in that particular column. In the product ID column, it will be maintained over there, right? So whenever reclustering is happening, the reclustering will remove all the data which are all not required for them. So whenever the data is being reclustering is about sorting and allocating a different micropartition. That is what clustering is about. So the data will be removed, whichever is not being used over there. So data will be removed, grouped together in a kind of grouping process, which we are doing in queries, and it will be loaded according to that particular groups. Because the data is being scattered over there, it will group all those data and then it will be loading it over there. Okay. So I think going on over there. So we'll be seeing further tomorrow. Tomorrow we will be creating one account in Snowflake, right? So every one of you, I recommend you to create an account. While creating account, it won't ask you for um, any kind of credit card or something like that. It is not required, right? So you need to have a valid email ID only, right? A phone number, any phone number you can give. Like. So tomorrow we will just see that, because we almost most of the theory we have seen, same thing only we are going to see here. I'm going to show you about the how the performance has been happening and all. That is being completed almost today. So how we are connecting to Snowflake and what all the devices is being used and what way we can connect, how we are logging inside, and what each platform means, what each region, we have to select a region. So what each region means, something like that. We will be seeing this tomorrow, right? The um, uh, how the web interface is being framed, everything. Right? So the concepts you just keep. It is just for your idea. I have given these concepts. Um, um, get through this one, and if you have more questions, we can discuss at any point of time, because this is what very important to understand the concept, how the data is being stored. Then only you can do some performance tuning or something, right? So that is what important. We'll discuss this more in later.
Sure, Murli, but can you please share? Uh, is it possible to share these slides?
Um, let me think about. I have not done any sharing of materials. So I'll be talking with the corresponding people, so in the management, and then I will be providing you this information.
Yeah,
Definitely, I will do some help about that. Definitely.
yeah, because this has very summarized information and the slides which you have,
Yeah,
so that's very
I
helpful.
understand that. I understand. So
Yeah,
I will see that how things happening here because we are starting just now only. So I'll just
Sure, sure,
get with this admin people how
sure, sure.
this has to be done. Definitely,
Yeah,
we will be doing it. Definitely, sure. Not don't
yeah,
worry about
Yeah,
it.
sure.
So I'll be providing something over there. And
yeah.
yes, so and we have
And if you can
one
suggest
more.
some places, means like in the
Sure,
first
sure,
class
sure.
you were telling like a lot of online documentation is available. If you can
Mm,
show us where we can go, and
yeah.
just for the sake of starting the preparation from our side. So
No,
um,
most. Okay, no, I understand. Most of the documents, what everyone is learning, even if you are going to do a certification, we have to rely on Snowflake documentation only. So just to go and search in Google Snowflake documentation, it will provide you excellent explanation, excellent material for learning in Snowflake. No other way to learn Snowflake. So Snowflake documentation is the only thing because it is gaining popularity nowadays, very recently. So maybe 2 years or something like that only, right? So very few YouTube videos or very few people are talking about that one. But I'll share some of these links with you, right?
sure.
Okay.
And
One of the ways
one,
Snowflake documentation.
yeah,
And
sure.
other than yes, other than that, I have one more person who joined very recently only.